We're doing 6-2 inverse functions and relations. So when you hear the word inverse, what word do you hear inside of that? Like, what's another word for inverse? Invert. That's like what I think. So you might want to even write that down, okay? We're going to invert. What's invert mean, by the way? Like switch them? Something like that, right? Same thing, okay? So basically you're probably inverting x and y today. That's what inverse means, all right? So if they give us a relation and they called it Q, these are totally random. These aren't like anything special. They just gave us some ordered pairs, okay? So they gave me 1, 2, -1, 0, and 3, -2. If I want the inverse of that relation, it's called Q prime. That little apostrophe or like tick mark is called prime. You literally invert all the x's and the y's. So this is no longer 1, 2, it's now 2, 1. This is no longer -1, 0, it's now 0, -1. Do you see how you literally just flip them, right? So this 3, -2 becomes -2, 3. Everybody okay? Super easy? All right. Inverse function. F is usually what we have. We have like f of x, right? Like we had yesterday. So the inverse is f to the -1. That's how we use the symbol to say inverse, okay? They're inverse functions, so f of a is equal to b and f of b equals a. It's okay if you don't understand that right now. We'll kind of come back to that later. I just wanted you to understand f and f to the -1 are inverses, okay? Here's how you find an inverse function. If they have f of x, what do we usually call that? Y. We're usually more comfortable with a y, right? So if it's f of x, go ahead and change it to a y. That's not actually inverting anything. That's just f of x is the same as y. Are you guys with me? Okay. So now here's where we're going to start the actual process. Step 2, reverse x and y. Like what we just did with the ordered pairs, you're going to do that the same. It's just not an ordered pair anymore. You're going to actually have an x and you're going to have a y. Okay. So you literally put x where y was and you put y where x was. Okay. Step 3, you solve for y because we're probably going to be graphing the thing anyway. So whenever you graph something, you typically want y alone, right? And then you go back and you say, hey, by the way, y is now f to the -1 of x. That's just saying it's the inverse function, okay? If you accidentally left it as a y, would I mark that wrong? No, right? It's just a nitpicky rule, I suppose you could say. It's super helpful because it's letting you know that it was the inverse of the original function, but if you kept it a y for a couple of days, I wouldn't freak out. By the test or the quiz, you need to know that it would be y to the -1, though. Are you guys okay? It's really not that bad. I'm not telling you anything super fancy. Identity function, f of x is equal to x. So, to test if two functions are inverses, to see if they're inverses, there's more than one way to do it, but this is probably a pretty easy one. Find Fogg and Goff, find f of g of x and g of f of x, just like yesterday, right? That's not new to you, all right? If they both equal x, then it's yes, it's an identity function. If they don't, then it's no. Okay, and I'll show you how to do that in a minute. So that's not new to you at all. Yesterday your answer was like x squared minus 10, so that would have been a no, right? If you get Fogg and you don't get x as the answer to Fogg and Goff, then it's no. Okay? So really nothing today is really that new. All right? Number 7, nope, just kidding. Number 11. Find the inverse of each relation. So we're going to invert these ordered pairs. So if that's 8, -1, what am I going to write? -1, 8. Very good. What's the next one? -1, -8. Next one. -8, -2. You're just inverting x and y. Last one. 8, 2. Anybody confused? Okay, great. All right. 17. Find the inverse of each function, then graph both. So I'm going to find the inverse, and I'm going to graph the original function and the inverse function. All right. So you can do that in any order. If you want to go ahead and graph that line, you can. It doesn't really matter. I'm going to go ahead and just start with the new stuff, though. That way, if I don't have time, like you should be able to graph number 17 without me. Do you see what I'm saying? So let's go ahead and step 1. It's already a y, so I don't have to change it to a y. So what do I do after that? Yeah, invert x and y. So instead of a y, I'm going to put an x, and instead of an x, I'm going to put a y. Is everybody okay? Super easy? So especially since we're going to graph it, we need to get y alone. This was the only new thing I've shown you today. After that, it's all old. How do I get y alone? Subtract 1 from both sides. So x minus 1 equals -2y. Everybody good there? Now how do I get y alone? Divide by negative 2. So when you divide by negative 2, a lot of you guys draw one big fraction bar and a negative 2. That's totally fine, but I think a lot of you guys also kind of don't simplify it correctly after that. So I typically put everything over negative 2. Again, the whole big one with a negative 2 is fine, but then you kind of forget to split it up. Okay, so especially because this is a line, right? Can everybody tell that that's going to be a line? It's x to the 1, so it's a line. So because it's a line, I really want to split that up so I have my slope and y-intercept separate. I don't want that. I don't really know how to graph that as a line. Okay, so this is really negative 1/2 x, isn't it? Do you understand that by now? Negative 1/2 x. And then two negatives make a positive, so plus 1/2 equals y. Is that okay? So that is the inverse. So technically, I should change it. How did we write it up here? I should change it to f at negative 1 of x. Well, really, they called this just a y, but that's okay. So I'm going to graph this line. Super old, super easy. Should be, right? And then we're going to graph our new one. And I'll show you how to tell that those are inverses graphically in a second. So let's go ahead and graph the first line. The y equals negative 2x plus 1. Where do you start? Up 1 on the y-axis, and then? And then what? What's your slope? Then down 2, right 1, right? That's enough, isn't it? That's two ordered pairs make a line. I'm going to go ahead and label it so I know which line is which. You should technically do that. In Algebra 1, you probably didn't do that very much because you usually had one line, so it was just understood which line is which. But when you have more than one line, you should label them so I know which one is which. Am I making sense? Okay, so the second line, where am I going to start? Positive 1/2. You just do the best you can. This is really hard to see, obviously, because it's kind of a small graph. So I'll just start up like 1/2, and then down 1, right 2. So again, that's kind of hard to see, but the lines aren't, so that's okay. So this would be y equals negative 1/2 x plus 1/2. Is everybody okay with what I did? All right, so the way that you can tell that they're inverses is if I were to graph the line y equals x, okay, that's the line y equals x. I've made it a dotted line because it's not really one that's there. If it reflects over that line, then they're inverses. That's kind of hard to see visually, I feel like. That's why I typically prefer the algebraic method. When we do this next one, I think it's a little bit easier to see that they're inverses. Lines are kind of hard, I think, to see. Have I lost you? You flip x and y, you solve your graph, right? So for this one, y equals 5x squared is really what we have, right? So y equals 5x squared. What do I do? Invert, right? So x equals 5y squared. Is everybody okay with that? What do I do to solve for y? Divide by 5. So I'm going to write 1/5 x instead of x over 5. It's not wrong to write x over 5. That's totally fine. I just think people are less confused this way. And it's still equal to y squared. So now what's in the way of y being alone? Squared. How do I undo that? Square root. You square root both sides of the equal sign. Whenever you square root both sides of the equal sign, what should you have? Plus or minus. Very good. Remember, that's a rule. Whenever you take the square root of both sides of an equal sign, you have to do plus or minus. So the inverse of this function, f to the negative 1 of x, is plus or minus square root 1/5 x. Okay, I ran out of room. I just changed the y to f to the negative 1 of x. Is that okay? All right. If you don't do that, am I going to give you like a 0? No, but we should. Okay? So now we have to graph it. Graphing isn't new to you, and even if you don't remember how to do it, what could you always do even though it's not like the best way to do it? What can you always do? T-table? Right? You could always do a t-table. I don't want you to right now, but you could, okay? So what shape is this going to be, the original graph? A U, right? Is it going to open up or down? Up. And then it's going to get fat or skinny. So we do have to do a t-table on this one because we don't really know how fat or skinny to make it. So let's go ahead and do just a really quick negative 1, 0, and 1, okay? So let's do 0 first. That's usually easier. If I plug 0 in, what's 0 squared? 0 times 5, 0. Okay, let's do 1. I prefer to do the positives first. I think most people are better at that. So what's 1 squared times the 5? Okay, what should we get here since it's symmetric? 5, but let's check it, right? Negative 1 squared is 1 times 5. Okay, so we're going to graph that one. We've got our 0, 0, 1, 5. This is hard to see. 1, 2, 3, 4. I think that's 1, 5, and negative 1, 5. Okay? So there's our parabola. All right? Tell me you're okay. This isn't terrible, right? Graphing this one is a little bit tricky. So that's really y equals the square root of 1/5 x, and it's also y equals negative square root of 1/5 x. Because that's a plus or a minus, right? We haven't gotten to graphing square roots yet, have we? Right? So eventually, not today, we're going to get to graphing a square root, just like we graphed a parabola in 2 seconds and moving it and everything. I think that's maybe even the next section. We're not there yet. I just want to show you really quickly what we're going to get to. A square root function looks like this, and then you manipulate it at that. So like when we had x squared, we always started with the parent graph, right? And then we flipped it sometimes, or we moved it left or right or whatever. So same thing here. That graph is the square root function, and we're going to move it depending on what we have. But you don't know that today, so we're not going to. So instead we're going to do a t-table, okay, and we're going to graph these. So the square root of 1/5 x, we'll do that one first, the positive answers. Okay, so you do your t-table. Typically on a t-table you do -2 to 2, right? If you have no idea what you're doing, that's where you start. But let's save some time. If I put -2 in, what's going to happen? I get a negative under the root. Can I take the square root of a negative number? No, it would be an imaginary number. So algebraically we can do that and we can figure out what it is. But graphically we can't graph that. So -2 is like not helpful to me, right? What about -1? Nope, not helpful to me, right? What about 0? Yeah, I could start there, right? So 0 gives me 0, okay? You can do 1, 2, 3, 4, 5 or whatever. I'm going to do something that's halfway pretty. If I do 1, I'm going to have to take 1 times 1/5 and square root it. It's not going to be pretty, which is fine. We're just graphing the thing, but I like to use my calculator as little as possible. So the next number I'm going to put in is 5. Why did I pick 5? So they cancel. The fraction cancels, right? Because what's 1/5 times 5 over 1? 1. What's the square root of 1? 1. So was I able to not use a calculator? Right? So that was helpful to me. Because you guys don't really know what shape that's going to be, I'm going to put another ordered pair in. Again, I'm not going to do 6. That's not very pretty. You totally can. I'm just not. So what's the next number that would be easy for me since I don't have a calculator on me? 10. Very good. So if you put 10 in, what's 1/5 times 10? 2. Okay, well, I don't know what the square root is. But that's okay. We're not going to go that far. So square root of 2 is like 1.411 or something like that, right? So that's fine. Really, I should go like super far, but I don't. That's not the point of today. The point of today isn't graphing square roots, so this is good enough. Is that okay? So we're going to do 0, 0, which is right here. And I'm going to do 5, 1, and that's probably enough. Where am I at? 1, 2, 3, 4, 5, 1. So this is my square root function, just like this one, but it was just compressed. Do you guys see how it was this one with a dilation to it? Okay. So now we're going to do the negative guy. Well, okay, let's not even do it, right? Here's why. Just like the rules from before, if I had y equals x squared, it looks like this, right? If I had y equals negative x squared, it flipped over the x-axis, right? So isn't it going to be this exact same thing, just flipped? You could do the t-table again if you want to. So let's save some time. The negative options. This still isn't going to work. This still isn't going to work. Do you see what I'm saying? I'm still going to get 0, 0. And this time when I put 5 in, I'm going to get square root of 1 here, but there's a negative sign out in the front. Do you guys see what I'm saying? So I'm going to get 5, -1 this time, which is a flip over the x-axis. Do you guys see what I'm saying? Okay. So if I were to graph that y equals x line, I think it's easier to see that this was a reflection over that line. It looks like this parabola is now here. But if you had forgotten the plus or minus, you would have been missing part of it. Do you see how important all those little pieces are? So If the only thing that I've confused you on so far is the graphing, don't freak out because we're going to get better at that. The whole point was really all this stuff that we did up here. That's really the point of today. So if you just need more help graphing, we'll get there later. Okay? All right. Determine whether each pair of functions are inverses. There's multiple options. I'm just going to save some time and stick with what the front said. The front said find f of g of x and g of f of x. We're going to do fog and we're going to do goff. If they both give me an answer of x, they're inverses. If they don't, they're not. So we'll do fog together, and then if we have to do goff, I'll make you do that one, all right? So let's do fog first, f of g of x, okay? And it's the same as f of g of x. Same as yesterday. None of this is new, right? All right? So if you're algebraic, we're going to go ahead and start there. So where do I start? Okay, so the inside, right? You start on the inside, this guy. So what is g of x? 2x minus 3. If you're algebraic and linear, this is the way that we did it first, okay? This says f of x usually. So I'm going to go to my f function and replace all the x's with 2x minus 3. Is everybody okay? So you distribute, that's going to be 4x minus 6 plus 3, which is what? 4x minus 3. Is that x? No. So are they inverses? No. Do I have to check goff? No. Do you guys see what I'm saying? So not inverses. Does anybody want me to do it the other way, the non-algebraic way, where I just said, hey, this goes in here? You guys are fine that way? Okay. All right. So let's do 34. We're going to start with f of g of x. I'll go ahead and do the first part again, okay? So again, if you're a this goes in here kind of a person, let me know in a second. I'm happy to do it that way instead. So I'm going to go ahead and replace g of x with square root of 3x minus 3, right? So in my f function, I have to do it this way or I get lost, okay? In my f function, what do I replace the x's with? This guy, right? Square root of 3x minus 3. That's the only hard part. After that, you just simplify. Before I actually do the math, does anybody need me to say what we just did again? Are you good? Okay, great. Whenever you square a square root, what happens? They cancel. Because that whole thing had a square root sign on it, and we squared the whole thing, they cancel each other out. Okay? So that's really 1/3 times 3x minus 3 plus 1. Do you guys get that? If you don't, I'll show you an example with like the square root of 4 instead. So let me know in a second if that doesn't make sense to you. Okay? So what's 1/3 times 3x? 1x. What's 1/3 times negative 3? Minus 1, and then still that plus 1. So just x. So we're halfway there. Fog gave us x, so we have to check goff, right? So I'm going to make you guys try goff. At least get it started, and then I'll do it for you in a second. Or this is a chance for you to ask, like, hey, I still don't understand why the square and the square root cancel, and I'll like show you off to the side what that means. So if you're stuck, that's fine. I'm going to do it anyway. Okay. I'm going to go ahead and get this one started. So if you're confused, go ahead and just kind of pause and look up here. So g of f of x means put f into g. So I'm going to not do it the algebraic way this time. I'm going to do it the geometric way for those of you that might need that help. Okay. That means put f into g. So put f into g. So I have, I'm running out of room, square root of 3x minus 3. I'm going to put f into g. So 1/3 x squared plus 1. That's, no matter how you do it, you should end up here. Okay? So distribute. That's going to be what? X squared plus 1/3. Is that right? No. What did I do wrong? Did I do something wrong? That looks weird to me. 3. Why am I'm saying, no, sorry. X squared plus 3 minus 3. Sorry, guys. I was looking at this twice. I don't know what I'm thinking. Is everybody okay? Sorry about that. So then 3 minus 3 is 0, right? What's the square root of x squared? Just x, right? Did they both give me x? Yes. So are they inverses? Yes, inverses. Anybody need me to go back for any reason? Are you sure? How many of you got that right on your own? Very good. I know that looked intimidating with all the x squareds and the square roots and stuff, but really it's not that bad once you actually just like do the problem. Okay? So don't get overwhelmed. All right, last question. Use the horizontal line test. I don't know that you've ever used that before, okay? So use the horizontal line test to determine whether the inverse is also a function. There's lots of different ways to do a problem like this. If they say use the horizontal line test, that's kind of an indicator that they want you to graph the thing, okay? So what we need to do is graph the thing. So again, t-table is fine. Eventually you're going to learn what x cubed looks like. So y equals x cubed looks like this usually. Here. We're not going to learn that today, okay? But we will eventually. It's super easy. You memorize this parent graph. So where would that parent graph move on this picture? Down 8. It would be this exact graph down 8. You don't know that yet, and that's not the point of today. So typically you do a t-table. So let's do a t-table real quick, okay? Typically it's -2 to 2. Let's see, do I want to actually do -2 to 2? Yeah, it doesn't matter. Let's just do like -1, 0, and 1. Just because all we need is just like that, the meat of it, the middle, all right? So let's do 0 first. That's usually easiest. When I plug 0 in, what do I get? Yeah, you get 0 minus the 8 is -8, which is what we just said, right? We're going to move that graph down 8. Let's plug 1 in. What's 1 cubed? Minus 8? -7. -1 is going to give me -1. -1 cubed is -1. Okay? And then minus 8? -9. This isn't symmetric like a parabola is. Do you see what I'm saying? Okay? So what that means is it's going to be this graph moved down 8, like I said, but you don't understand where that graph came from. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, -8. -1, -9, and 1, -7. So before today, that's not good. It should go up a little bit, sorry. Before today, you didn't really know what shape that was going to be, but it's kind of like a curve, a curvy snake that goes up and down. I don't know how to explain that. It's not a U, it's not a V, right? That's gone. I need to erase that. That's confusing. Get rid of that. Okay. So again, more than one way to do it, but we've graphed the thing, even though that's not what they asked us, right? Before today, we always had the vertical line test, right? The vertical line test was this way, up and down, to see if something was a function. They're asking us if the inverse of this graph would also be a function. So that's called a horizontal line test. So I don't have to find the inverse of this graph to see if it's a function. I can just look at the graph on its own. Does this pass a horizontal line test? Right? So does this ever hit the graph more than one time? No, so it passes it. So what that means is the inverse is also a function. I'm going to say it again. This graph is a function because it passes the vertical line test, but that's not what they asked me. That's just what we're used to. They're saying, hey, without actually doing all that work, see if its inverse is also a function. So let me show you what the inverse of this would look like. Again, you don't understand why I'm doing this in 2 seconds today, but later you'll learn it. The inverse of this is going to look like that. That's what the inverse would look like. Is that a function? Does that pass the vertical line test? Yes, but I didn't have to know that in order to get there. All I had to do was do the horizontal line test to see if its inverse was going to be a function. If it passes the horizontal line test, then its inverse is going to be a function. If it doesn't, for example, I don't know, something like this, that one's fine, just kidding. Something like this, That does not pass the horizontal line test, which means its inverse, this guy, would not be a function. That's kind of a lot, so if you get confused, let me know. Do you guys have any questions? Are you sure? Okay. Not really.